So hi everyone. What I'm going to talk about tonight is a subject that I really like because it's related to optimizations, and it's about how to detect or hunt for unoptimized queries that are running on a cluster. So I'm a lead data engineer. I've been working with ClickHouse for the past 5 years. Well, I help a lot in data modelization there. And I also worked internally to build some toolings to help users use efficiently ClickHouse. So I built a client for that, type-safe client in Scala. And these days on my free time, I'm working on a personal project related to ClickHouse. And through that, I found some security vulnerabilities. And so I'm currently top 3 researcher on the bug bounty program. So first good question, I believe, is how do we end up with hunting non-optimized queries? Well, when you are using ClickHouse, what happens most of the time is that you have a big cluster, multiple shards, and you have multiple entry points to receive queries. So it can be one web server which have lots of paths that will build the different queries. It can be multiple web server, it can be internal users, BI, data scientists, etc., that are querying your cluster. So you have a wide range of users or service from where your query can come from. Also, all those have a different maturity level in regards to ClickHouse. It's very important to notice that ClickHouse almost executes your query as it received it. There is almost no optimization being applied. That means that if you are good at writing queries, you really know the tricks of ClickHouse, you can build efficient queries, but for newcomers, it's very difficult to build the best queries. And also, the load of your cluster is going to change throughout the day. So if you are testing a query maybe during the morning because there is not lots of queries, you will say, oh, my query works just fine and doesn't impact the cluster, it's nice. You put it in production and during peak hours, it actually creates an issue. So we end up with having to hunt for those non-optimized queries. In this talk, I'm going to focus only on select queries. And on those, I'm removing everything about dictionaries and materialized views because they don't necessarily appear in the table that I'm relying on. So the first question is, if we want to hunt for queries, where do we find them? There is one table that I really like. Frank just talked about query log a little bit. I really love that table. There is lots of information in there. Here you can find a few examples like the memories that was used. You can retrieve the queries. Inside profile events, you will find CPU time. You can find data about the network time. So it's quite an interesting one. And in particular, there is one field that I believe is super useful, not much used. It's called log comments. So it was introduced in ClickHouse for their test. They wanted to write the name of the test as a comment of the query. And that field is actually a string that can be super huge, same size as the query. And you can write any information that you want. So for example, what I suggest is to use it as a CSV. And you write as a key value some metadata that you want to log with the query. That can help about from where does it come from. It can be about some technical metrics like what I call nested subqueries depth. I will talk about it later. And it can be also business metrics like when you called me, it was about different countries. There was here one query, one country that was asked. And if you want to retrieve the data, you can use the extract function. And with the extract function, you can see you write a small regex and you retrieve the values that you wanted. So super useful field. So I'm going to present two strategies. The first one is quite simple, a fully manual one. It serves for quick wins. The idea is that we reuse query log and we can do some top 10. What are my top 10 queries using the most memories, the most CPU times? So it's a bit documented on ClickHouse, if you on the link. So I'm still adding the network part that is not mentioned there. The network part is super important because your query can be distributed on the whole cluster, and sometimes it changes a lot of data. So you might have fast queries, lots of fast queries that don't use much memory, but that they exchange so many data that they are actually creating a bottleneck on your cluster. So top 10 is going to find some edge cases that you have that are good to solve. But then the most interesting strategy for me that I worked on last year is to leverage machine learning and say, I might have on my cluster millions of queries running every month. That definitely is something that can happen. And so it's kind of, you are trying to look for the needle inside your haystack. If you have many needles, but how do you find them? So the idea is to use machine learning here. So in one, you have your cluster. So as we have seen before, you can use the extract function. We can retrieve some, well, all the queries that were launched on the cluster. And we can say for each of them, give me some metrics that I found, for example, in query log, in the log comments, or metrics that are provided by ClickHouse itself. And I will need a value to predict for my machine learning model. So execution time, for example. Then the idea is to build a machine learning model on top of it, and then ask that model, okay, if you are able somehow to predict the query duration just by reading the query, just by reading the few metrics that I provided, how do you know what makes that query slow? Just give me some tips. Give me some KPIs that tells me that query might have an issue. So this is the explain part. And when you have that, you can build some criteria on your own, and then look for queries inside ClickHouse, inside the query log table. And then you analyze again manually. But you know that you have some patterns, you have some trends that are important. So I'm going to dive in that. In that scenario, what I used is all the commits of the ClickHouse repository. It's a dataset provided by ClickHouse. I built manually 11 queries, some being optimized, mostly non-optimized. And I took 4 metrics in log comment to help me to find what might be an optimized or not query. The first thing that is important is to have a context and to group queries by context. For me, a context here is, okay. So for me, the context here is a table. Tables might have different engines and not have the same number of lines. So if you want to analyze the impact of something, you need to use a common context. So here for me, it's the table. Then I'm adding a first technical metric that I call nested subqueries depth. So the main select that you see on the top left, for me, has a depth of 0. Then for all the subqueries in that query, depth equal 1. If the subquery have another one, depth equal 2. So I'm counting the maximum depth. Maybe it's interesting, maybe not. The idea is to log as many metrics as we can. Last year, I defined about 45 metrics, some technical, some business, and it proved to be quite interesting to know what's useful and what's not. Then I had the number of where conditions and of the main query, only on the main query. And both of them are, I'm looking for a hash, commit hash inside a subquery. So I have 2 in subquery, and that's my third metric. And the last one is join. So it can be left outer join, global join, whatever join you mean. In that query, I don't have them, but there are some queries that I use with them. So those are my different metrics. And something a bit weird that you might have seen is I'm using a sleep function. Don't mind it so much, it's just because the dataset is small. So I wanted to emphasize reading the data from that table. So I'm just making it slower on purpose. So the first thing that we want to do is to download the dataset. So same as before, we extract the different metrics. And the last field is query duration in milliseconds. It's going to be the values that I try to predict. And then everything else is happening in this script that I'm going to emphasize a little. By the way, in the commentary of the slides, all the queries that I'm showing are available. So if you get the slides afterwards, you will have everything. Here, okay. Here, the first thing is to read the data that we just exported from ClickHouse, and I'm splitting it into 3 data sets. The first one is used to train the model, the machine learning model. The second one, the fitting dataset, is used to say, try not to hardcode too much from the training dataset. When you receive new data, I want you to be able to differentiate and still be able to predict kind of correctly. And the last one is evaluating dataset. It's just to check the model, check if it's very bad, good enough, or extremely good. We don't care about being extremely good because what we want is a trend. We are not looking to build an efficient model, just something that is enough to give us some criteria. Yep. Then I asked my friends, data scientist friends, about, okay, I want to build a model. What do I do? They talked to me about Cat Boost, which was released by Yandex, so same as from where ClickHouse come from. And it's just 2 lines, just to build the model. So it learns by itself. I don't exactly care about how it's done internally, but it works and it's fast. And then you have the last part, which is the very interesting part about how to explain the model. So it's something called SHAP. And SHAP is really there to say, so the first thing that I'm saving is a summary. So it's going to look at the different metrics that we used, and it's going to tell us overall what happened, how are they impactful or not. And then I'm saving some dependence plots, and the dependence plot is looking metric by metric and diving into it. So what it looks like is something like this, and there is a ton of information there. So first, on the left, we have our 4 metrics. Great. And what you see afterwards in the chart, it's not lines, it's not vertical lines, it's actually tons of points. It's just that because I have 11 queries, they tend to have the same results. So they are just on top of one another. But 1 dot is 1 query in our training data set. Then what you have is understanding the chart. So on the bottom, the x-axis, you can see the SHAP value. When the SHAP value is 0, it means that for that metric, for that query that is on 0, the metric was not useful, did not add any impact on the prediction. When it's negative, it means that it allowed to reduce the KPI, so the metric to predict. So here, it means that the query duration was small, so the query was fast. And then when it's positive, it means that the query was slow. And something that is super interesting in that chart that I'm looking for first is what we see with the in-subquery metric. So it's spread really from left to right. And on the left, you have the blue color. The blue color, what you can see on the right, it means that the number of in-subquery was very small, so potentially 0. When it's red, it means that we have a lot of them. So here, we have a gradient from left to right. The gradient means that the more in-subquery we have, the slower the query, the final query. And second thing that I like about it, it really goes to the negative values. So it really helps to have a fast query. and it goes very high into the positive values, so it has a very, very, very strong impact to slow the code. And then, so obviously we have only few points, few dots, because my dataset was small in terms of query executed. I did not have a full cluster used by thousands of users. But here you have the charts about the in subquery. And you could see a pattern that is quite linear. So you could say, okay, I want to analyze queries that are running on my cluster with, for example, 6 in subqueries. Because is it normal to have 6 in subqueries? Maybe, but it feels like a code smell. It feels like something that is maybe not normal. So something interesting. So that would be one criteria. You have nested subquery depth. Okay, it's interesting because it jumps directly as soon as you have at least one. But after that, it looks stable. So you could say, oh, I need to look anything that has a nested subquery depth. But here we don't really care because we have already to check in subquery equals 6, and all queries with in subquery equals 6 definitely has a subquery. But that could have been interesting as well. We have the join. The join, I would say we don't have enough data. It might look interesting if we have a lot of time on our hands to analyze, but I would say not enough data. And lastly, you have the where conditions, on which I could have 2 different interpretations. So we can see on the far right that we have a blue dot, okay, and we don't care actually about the color. It's just sharp trying to make some link between 2 metrics, so the color is completely useless. But we can see that it seems to grow to make the query slower, but we have queries with lots of conditions that are fast. Makes sense because you can have conditions that are very slow, that takes, for example, in subqueries that contact your wall shards on your cluster, and you can have just 2 greater than 1. So a condition doesn't mean that it's going to be fast or slow. So I could say, oh, maybe we don't care. The second interpretation is that we see that it grows very fast, and then we don't have any dots. So either it's just that we don't have any queries with lots of conditions, or it means that the queries timed out. Because here, my dataset only contains queries that were successful on the cluster. So the fact that it's missing some dots might say maybe the timed out. Not here, but it could be another interpretation. So, okay. With that, we were able to define some criteria. Let's use those criteria. And here, I saw one query with 6 in subquery. They are quite similar, and we can see that someone is trying to look at the different commit authors in ClickHouse, but only for commits that include specific files. Like, I want committers that impacted the Docker folder in ClickHouse, but not the documentation of Docker and things like that. So I can understand why they wrote that query. Still, it's not optimized. And here, we are at the same point. Whether we used the fully manual analysis or the machine learning analysis, what we found is queries that we hunted that are non-optimized. Now, the question is, what do we do with that? There are 3 questions that are super important. The first one is, how many queries have that pattern? If I have only one, I don't want to spend time trying to optimize it. If I have 10% of my cluster, of the queries on my cluster that have that pattern, it means that it's super important to spend some time on it. And spending some time could be just spending 1 day on a POC. Happened to me, I ended up with a queries with more than 1,000 rows. Just when you format the SQL, it was more than 1,000 rows. And yeah, I spent 1 day just to manually optimize the query. The second thing is, what would be the impact? So if I find some optimizations, what will they change? And the last point is, well, if we found some optimization, potential optimization, it's how much time will be required to change the queries that are running on the cluster. So for us, for that query that we saw before, how many other queries have that pattern? Again, our lovely table query log. We just add, you can see a little bit. So I have hash in something, and I saw that the pattern was the user used where starts with a path and where not in. Okay. So I got that. And we can see here that I have 300 queries with that pattern, and it's 27% of the queries on my cluster. Obviously, I made the queries to have good numbers, but. Then the question is, okay, 27% of my cluster, so it might be interesting to work on. First thing to do is rewrite the query. So you can base that on your knowledge, but there are so many functions, so many features in ClickHouse. Taking a look at the website to see if there are other solutions is important. You can ask on Telegram to have additional help. It's always good to discover new features. Then you want to benchmark what's going on, what did you change, and then estimate. So you know how many queries have the pattern, so you can try to estimate the impact it would have. And it could be, maybe it's only 0.1% of the queries on my clusters that are impacted, but they all are for the same feature, for one path in my web server. In that case, it might mean, my customers have an issue or have some slowness where they are browsing my solution, and I know why. So here, my idea would be to write a single subquery. Looks like it works, it provides the same results. So that's what I would do. Then I can benchmark it. For that, I could use clickhouse-benchmark. I'm not going to enter into how I use clickhouse-benchmark. It could take a bit of time. But we can see that the previous query took about 21 seconds to run. The new one, 5 seconds. So we have a 4-time improvements. You can also see that you have number of queries here. I ran in 5 minutes. Previous query, only 14 of them at the time to run. With the optimization, 57 of them. So good, happy. And lastly, how much time will be needed to fix the problem? It really depends from one company to another. It's lots of communications. It's lots of debate about prioritization between projects. And ideally, it's just a data scientist running a script on its own, and it can just change that. Super nice. It can also make some good internal talks to teach others in the company, hey, I found an optimized queries, and there was this trick that was useful, and share knowledge with the company. So lots of things that can be done. And with those two strategies, I wish you a happy hunting. And I will repeat, but I'm looking for a job. So if you are looking for a data engineer or backend engineer, I would be happy to help and hear your opportunities. Thanks. Any questions? Yeah. The question is there some explain? Yes. You do have that in ClickHouse, so that could be useful when you hunted a query, and you can use then the explain. I haven't used that much, and I find it a bit hard to use. But I heard also about stories of people that were successful in using it, so yeah.
One question on other statistics. Like, did you look at the number of bytes processed, the number of like anything internally about the query plan, or was it purely content analysis for you?
For me, it was purely content.
Only content. Okay.
Yeah. So you could try to say how many rows were read, things like that. So when I did the analysis in my previous company, we had only 2 tables and 2 different, well, 3 contexts in my case. So it didn't make much sense. They all are querying lots of data. But one of the metrics that I had was number of days being asked, for example. It was a business metric. And yes.
Yeah, one of the things that we've seen, at least for other tools like Databricks, is that they provide some query plan and they have other steps like shuffle steps, which will then tell you additional information on how many rows are being moved around just to specific queries, which in combination with your content analysis provides for that much more richer information.
I didn't saw that in the explain. So the explain is supposed to provide you the query plan. I didn't saw the number of rows that would be read in that explain statement. But yes, and that's also why I added the network part in the metrics that I discussed before. It's because sometimes you will see, oh, I spent 1 second in network for that query. While, yeah.
Thank you.
Yeah. Thank you for the presentation. It was very interesting. I was wondering if there was a metric to know if a query is consumed by an external tool, a downstream tool. Because if a query is non-optimized and very expensive, we can just delete if it's not used by any business stakeholders and so on.
So I'm not aware of something like that. Maybe you could, well, first use log comments. If you can say from where does the query come from, it can be where it's going to be written to, things like that. You can try some correlation, I would say. Or you might have some select into, and then the data is stored, for example, in S3. So then you could do just a search on the query.
Okay. I meant things like exposure. I don't know if you are familiar with exposure, like in DBT when you have models. Models are feed some exposures like table dashboard, metabase, and sometimes you have some queries that are very expensive, and we don't know if they are used by any business stakeholder. And sometimes we found that they are not used, and the simple thing to do is just to delete the query. It's not time cost expensive, and it's easy.
Yeah, I'm not aware of anything about that, about doing some observability.
Thank you.
Thank you, everyone.
All right, thank you. Just one last slide that I just want to share really quickly. That's okay. Yeah. All right, just want to say thank you, everyone. Thank you to the speakers. Thank you for attending today. We're going to hang around a little bit, but please join some of the community Slack, some of the community pages. I just had a quick look. There's almost 7,000 community members on the Slack channel, which is great. We're constantly answering questions as well, so please jump on and feel free to reach out to us. If anyone wants to speak at a meetup in the future as well, please let us know. We're definitely going to come back and have more sessions for ClickHouse users in Singapore. And yeah, so we're going to hang around a little bit more. So thank you very much for your time, and Shopee for hosting as well. So thank you, everyone.